So let me start this recording. The chain rule is basically how we derive composite functions, which you know from studying functions that a composite function is a function inside of a function. And so if we look at something like number 6, this numerator is a composite function. I like to think of it like a big picture, small picture, right? Your big picture is the square root, and the small picture is the x minus 1. So essentially you have a function inside of a function. And so anytime we have, or we're using chain rule, we are evaluating the derivative for that function inside of a function. It's really about deciding what is your big picture and what is your small picture, right? So the way that we do this, and this is Leibniz notation, is they say, well, in order to find the derivative, let's say that dy over dx is the derivative of some composite function. They say, okay, well, take the derivative of y with respect to u times the derivative of u with respect to x. And we'll review what that means. But this is your chain rule. Now, dy du, let's look at that first. In order to do this, I have to decide what's my big picture function and what's my small picture function, right? My big picture function is the square root, right? So I talked about this before, and I mentioned this yesterday, that substitution is a really important part of calculus. We're going to be using the idea of u substitution a lot, and that's what actually we're going to be doing here. So we have to decide what is our big picture. So my big picture is the square root of u, which I can rewrite as u to the 1/2. Okay, that's my big picture. Now u is my small picture. It's that thing inside of the larger picture, which is just x minus 1, right? So u is equal to x minus 1. So we've got our big picture and our small picture. This is our big picture, and this is our small picture. The chain rule says take the derivative of the big picture, the derivative of y with respect to u, which makes sense because this, if we look at our big picture right here that I've starred, y equals the square root of u, that is y in terms of u. So that is what we're going to take the derivative of. So it says take the derivative of the big picture and multiply it by the derivative of the small picture, du, with respect to x, okay? So just looking at the big picture alone, I have u to the 1/2. What is the derivative of u to the 1/2? Use the power rule, which says what? What is my dy over du? What does that equal? What do I do? It's u to the 1/2. What do I do with the power? Okay, Akil. Take the 1/2 and you move it, what, Shirley? You move it up front and you do what to the power? Yes, right. So the derivative of the big picture, dy over du, is 1/2 u to the negative 1/2. Okay, do we get that? That's the derivative of the square root. That's the big picture function. And we say, next step is to take this, to find this du over dx. Which is just 1, right? So the chain rule says take that dy over du times du over dx. So we're going to do that, and we're going to go ahead and replace u with x minus 1. Okay, we're going to substitute it back in. So the derivative of the numerator is going to be 1/2 times x minus 1 to the negative 1/2 times 1. That is dy over dx. Does that make sense? Now, in order to find the derivative of a quotient, you have to use quotient rule, okay?
Welcome back. Well, now...
So you have to use quotient rule, okay? So quotient rule says low d high minus high d low all over low low. I went over that before you left. So we're going to apply that rule. So low d high minus high d low all over low times low. That's our quotient rule. So, do we have any questions so far? I just wanted to show you how to find the derivative of the numerator because that's what we're going to have to do anyways. Take our denominator. So if we look back at the original question, our denominator is 1 minus 2x. You're going to multiply that by the derivative of the high, which is the numerator, which we already found, which is 1/2 times x minus 1 to the negative 1/2. So times 1/2 x minus 1 to the negative 1/2. And I'm going to put those little brackets around it just because I'm dealing with a lot of parentheses here. It's low d high minus high d low. So I look back, my original numerator is that square root of x minus 1 d low is the derivative of the denominator. If I look back at my original, the denominator is 1 minus 2x. So what's the derivative of 1 minus 2x? Look back on your notes. Look at 1 minus 2x. What is the derivative of 1 minus 2x? Negative 2. Right, because you're subtracting. So times negative 2. Okay, so that's low d high minus high d low all over low low. Low low is 1 minus 2x squared, right? So that's 1 minus 4x plus 4x squared. Okay, so I did a little shuffling. So let's go ahead and simplify this. I'm going to take that 1 minus 2x and I'll leave it alone. I'm going to take that 1/2 times x minus 1 to the negative 1/2. I'm going to move things to the denominator. So that's really just 1/2 times 1 over the square root of x minus 1. And that latter half of the numerator, just leave it negative 2 times the square root of x minus 1. All over 1 minus 4x plus 4x squared. Questions? Okay, plug in 5. And let's see what we get, and then we're going to verify it with the calculator. So go ahead and do that. Oh, I don't know why I put a negative here, it should just be 1 minus 2x. So this becomes 1 minus 10 times 1/2 over, or times 1 over 2 minus -4 all over 1 minus 20 plus 100. Okay, so I'm just plugging in 5, right? And I get 7 over 324 as the value of my derivative, which is the slope of that tangent line. Questions? No? Okay, let's verify this on. Freeze this so you can take a look at it, and then get out your graphing calculators, and we are going to verify the answer. So let me go ahead and switch screens to what you're seeing on the notes. All right, so if you take a look at number 9, I know I have to use chain rule because I have a big picture, small picture situation. I have a 2x plus 1 raised to the 3rd power. The big picture being raised to the 3rd, and the small picture being what's inside of that, which is the 2x plus 1, right? So I mentioned this yesterday. I didn't really do a lot of U substitution with my calculus teacher when I learned the chain rule. I just sort of knew what to do. But it is really good to write out the U substitution part every time, just because it's good practice when you deal with the most complicated functions. So let's once again identify what our big picture is and our U is, like we did before. So we said the big picture is to the 3rd power, right? So we're gonna say, whatever my big picture is, I'm just gonna forget about the inside, and I'm just gonna replace the inside with a U to the 3rd, just like I did with the square root of U, right? My U, in that case, when I substitute later, would be 2x plus 1, right? And the chain rule says the derivative of any given composite function is the derivative of y with respect to u, which again is this part, times the derivative of u with respect to x, which again is this part. Okay, so, and you can just pay attention. You don't have to write these notes if you just want to like listen to what I'm going to do. That's fine too. So I'm going to go ahead and find the derivative of y with respect to u, which is that, okay? That's a power rule function. Power rule says bring the power to the front, subtract by 1. So the derivative of y with respect to u, remember that with respect part is whatever is on the other side, so that if it's in u's, it would be with respect to u, or if it's in x's, it would be with respect to x. So that is 3u squared. Right? Now that's the dy over du times du over dx. So that part of it, let's see, let's do blue, darker blue. So du over dx is going to be differentiating the inside function, which is just 2, right? And the chain rule says multiply both of them together, and we can substitute our u in. So, therefore, dy over dx is equal to 3 times 2x plus 1 squared times 2, right? Do we get that? The derivative of that composite? Now, if I actually look at what the question is, it's a multiplication problem. And multiplication means what rule? Not quotient, because it's not dividing. product rule, right? And product rule said first times the derivative of the second plus second times the derivative of the first, right? So this is a combination of chain rule and product rule. So let's go ahead and do this. First times the derivative of the second. So that's going to be first, which is what comes first, which is square root of x, times the derivative of the second. I already have that. That's going to be 6. Let's just replace that 3 and 2 with a 6. 6 times 2x plus 1 squared. So first times the derivative of the second plus second times the derivative of the first. My second is plus 2x plus 1 cubed times the derivative of the first. What is the derivative of the first? What's the derivative of this square root of x? Yeah, 1 over 2 x to the what? Yeah, negative 1/2. Or you could rewrite that as 1 over 2 times the square root of x, right? If it doesn't say to simplify, you can just leave it like this. Questions? No? This here, freeze the screen, give you time to write it down. Let me start recording. So this IB exam style question is going to combine binomial theorem with the derivatives and the chain rule. Okay. It says let f of x equal the quantity x squared plus 3 to the 7th. Find the term in x to the 5th and the expansion of the derivative. Okay. So find the derivative, right? The derivative of what? X squared plus 3 to the 7th. That's a chain rule question because it's a function inside of another function. So let's go ahead and find the derivative first before I worry about the binomial theorem. Okay. So dy over dx is equal to derivative of y with respect to u. You don't have to write this out each time. I just do just to remind you that that's what we're working with. Y is equal to u to the 7th. U is equal to x squared plus 3. Find the derivative of the big picture function, which is dy over du, which is equal to what? What's the derivative of u to the 7th? 7u, yeah, 7u to the 6th, right? Great. And now I'm going to differentiate the u part of it, du over dx. So derivative of u with respect to x is going to be what? 2x. Great. So now I'm going to list out that derivative. Dy over dx is equal to 7 times 2x to the 6th, or not 2x to the 6th. U is x squared plus 3. 7 times x squared plus 3 to the 6th times 2x. Right. Okay. Question so far. Now we have to look at the expansion, which means we have to go back to our formula booklet and remind ourselves what we need to do. So at this point, you turn to your formula booklet. I'm going to write this down just in case there is a method mark for recognizing that I have an expansion. And let's think of the question itself. Find the term in x to the 5th. right? And so I'm looking at this. How am I going to find the term in x to the 5th? Well, let's go ahead and simplify this to 14x times x squared plus 3 to the 6th. Well, I know it's going, my n is to the 6th, right? That's going to be my n value. I have to figure out what my r value is going to be. I want x to the 5th. So what's my r value going to be? Not 5, one more down. 4. Okay, think about that. Now that I went through that long explanation, and you can stop me and have me re-explain it again if you need me to. So I have 14x, and then I have that x squared, because that's 6 minus 4, right? And then I have times the 3 to the 4th. So remember, you can plug this in your calculator and see r 6, 4, and that's under your statistics option. Okay. And I believe that gives you 15. So you have 15 times 14x times 81 x to the 4th, which is 17010 x to the 4th. Questions?
What does it say?
CR. N choose R. N choose R. You have N items and you want to choose however many. And this is under your statistics button in your calculator. This is a paper 2 question. I pulled it out of the paper 2 IB questions. Questions? It's a lot.